Okay, recording started. We're going to talk about mobility today, among other things. So, mobility means any device you can pick up and take with you. It is generally going to refer to laptops, phones, tablets, can also be smartwatches. GPSs have kind of gone the wayside because they're in phones and tablets and laptops, but you do still see them in the scientific community to take measurements and trails of their remote sites, stuff like that. Can also mean portable video game machines. And generally, it means anything that's going to run off of a battery. This kind of changes your entire philosophy of how a device should work and what it should do, what you can expect from it. Efficiency is suddenly more important than power because you want the most battery life possible. Heat management is the thing. That's the other reason you don't want to run a lot of power through a device because that makes more heat. This is all about battery life, and saving space adds complication to this because you don't have a lot of room for cooling. You don't have big open spaces to blow air through the computer. You don't have room for a giant heatsink. You have to cool this thing with really no room around it. And then mobile functionality means your typical device is going to have a bunch of other devices included in it because they have to be kind of on their own. They have to be everything. An iPhone is a screen, it's a Wi-Fi adapter, it's a microphone, it's a webcam, it's a touch interface, it's a GPS, it's got a cell chip, it's got a hard drive, like it's got a motherboard to control all of this crap. In some cases, it has a fingerprint scanner, usually has an accelerometer. We'll get into that, but there's a lot of different devices crammed into these things. The accelerometer, of course, detects movement in whatever direction you want, acceleration being a change in velocity, basically. What direction am I moving? It's got this weird thing in there, and as you move it up or down, or whichever direction you move it, that thing inside has inertia, and then it measures, oh, we're now going up, we're going north, we're now going west. Like it can tell micro changes in your acceleration, your movement. So it constantly knows your velocity. It knows usually which way is up, which way is down, etc. In a greater sense, GPS knows where it is. It likes to verify its position with at least 3 or 4 satellites, and then it can tell you within usually 50 feet is the general barometer for this stuff, where it is. You're on this street, you're on this street corner, you're in this town. It is a constant indicator of where the heck you are. So it's pretty useful. And it used to just be in these little handsets with a little screen, and you can mark your location. This is what scientists still carry around. Some of our archaeologists, when they go out on digs, they use a GPS to follow a set path of different sample sites they visit. But this technology is built into phones, it's built into cars, it's built into a lot of different things now. And a combination of accelerometers, onboard cameras, and GPS is allowing some cars to kind of drive themselves, either autopilot out on the highway that sort of keeps you between the lines, maintains speed, distance, or this auto parking mechanism using close range radar. It's sort of detecting where these vehicles are and parking in there. But it can also drive through the parking lot. The fact that these devices know exactly where you are is in and of itself an invasion of privacy. It's one you've authorized, like you've told Apple or Samsung or AT&T, Verizon, whoever your provider is, it's okay if you know where I am, but I don't want you to tell anybody else, of course. You don't want them to tell your ex-boyfriend, you don't want them to tell your boss where you are necessarily, you know, you you don't want this data just publicly available. But it is available to some, depending on states, jurisdiction, various laws, rulings. Your GPS data is available through search and seizure stuff, through other laws, and in a second, I'll show you a map that kind of better indicates where it's available to who. And then sometimes they can only tell where you've been in the last week. Sometimes they can tell exactly where you are right now. Again, depending on the jurisdiction. So you can see in the South, no warrants required. You see here in Illinois, we have some, what this map labels, some protection. Where it's green, you got to get a warrant, which means cops have to have probable cause. They've got to go to a judge. It's a much more involved process if they need a warrant. And then, yeah, location information unprotected are probably the scariest places. And they're mostly rural by the looks of it. Okay. Another big mobile device, laptops. This is all the parts of a computer crammed into one. I'm going to say a few things here that are very obvious. A laptop is a computer with a screen, keyboard, and in place of a mouse, you have a trackpad. It's probably the most common thing you'll ever find on a laptop is a trackpad. You can see it's also got a headphone jack, a USB port. This one's got USB-C. It's got a microphone port. It's got a nice backlit keyboard. This is an Alienware, so it has additional ventilation and a big butt sticking out the back. That is a big cooling unit along the back because this probably has a beefy video card in it. This is what typical ports look like on the side of a laptop. You guys can recognize all of these. This is VGA. This is an Ethernet port. It just has a little door over it. This is HDMI, and you got two USBs, and then obviously the headphone jack's off screen a little over here. These are the ports on a present-day MacBook. Weird as that is. It's a bit restrictive, I can tell you, to only have USB-C, and it means you need devices like this, which is sort of defeating the purpose of only putting two ports on there, but whatever. You live with it, or you can use one of these. These are also useful. You see this guy's turns one USB port and provides another one so you can plug your power in here because USB-C normally also carries power. Then you got VGA HDMI. This looks like mini DP, which is DisplayPort, but it's just smaller. And then an Ethernet port. So this is all to save space, really. To make this thing thinner, lighter, so people can carry it around farther without being annoyed by it. This causes so many different problems. It limits what graphics card you can put in there. This chart's kind of grainy because it's old. You see it's from 2010, 2012, back when apparently we only had 640 by 480 resolution. But anyway, you can see that 100% graphics performance on a desktop is right up here. And in 2010, we sort of accepted that you could have a 480 in your desktop, but you had to have the 480 mobile. M is mobile in this case, in your laptop. And it's only 40% as good. By 2012, we were closing on 60% as good. By 2014, we're closing on 80% as good. So this is coming along. Laptop chips are kind of closing this gap. And this chart's a bit much, so let's back off part of it. Just look at this. What about the 2060? Present day now, you see that they have the same number of cores, the same overall processing capability, but the laptop version is going to go at a lower clock cycle, slower. It uses less electricity, it generates less heat, its maximum speed is lower, its RTX performance, ray tracing performance is lower, has similar memory, or same, and then it's TDP, which is thermal design point or thermal design power usually. It's just the most heat this thing's going to generate. It's going to live in this area. And you see it has to be just about half. It has to be just about half of the desktop to live in a laptop. But having a 2060 in a laptop means you can run a VR headset with it. So that's pretty good. Of course, there's some other things in common. You still have a BIOS. You still have a motherboard in there that the BIOS can access through F2 on Dell or whatever the key is for different machines. You still have a post when it comes up. You should see the company logo, maybe some other stuff. Or it still has beep codes. All those normal things you're used to. A laptop is going to do that. You still have to have an operating system on there. It could be Windows, Linux, Mac, whatever. Most of the parts are the same. The power supply, laptop powers are all bespoke. They're specifically designed for that particular laptop. You can't take a power supply out of this Acer and go throw it in Dell or a MacBook. It probably won't fit. It's different voltage. It's designed exactly for this battery and this power demand. So everything's kind of specific. That means it's more expensive, it's more trouble, and it's more difficult to replace. But see here, this one has a heat sink over the processor and a tiny little fan. So obviously this one has better cooling than many laptops do. It does have a graphics chip over here separate. It has a motherboard and a processor. So it does not have integrated graphics. This, for its time, was a nice laptop. See the LCD screen up here? This is basically a laptop torn to all its pieces. This is an old one, 2005, but it doesn't look any different than this now. Looks a little fancier. There's actually a little less space to work in here. It's more annoying. So, while we're talking about laptops, I've just added this bit because right now there's something funny going on in the laptop slash processor world. Several years ago, 15 years ago, Apple switched to Intel chips, which means you can have a Hackintosh where you're in the macOS on your PC. You can install Windows 10 on your Macs because Macs and your average PCs use i7s. They use i5s. They use Intel. They can even, in theory, use Ryzen's on a Hackintosh. So they can all run the same stuff. They're very similar. But Apple, years ago, decided that they had licensed these ARM chips, which are mainly for mobile. They're different. They're more efficient. They're more power per electricity, but they were never scalable up to the desktop level. Well, Apple's a company worth $1 trillion ish. It's got a lot of money in the bank in the last 10 years, and they have been researching how to make their own processors. And we are watching them in real time now. Check it out on YouTube. They are ditching Intel. They are going a different direction, and they're producing their own processors. And there's a lot of disadvantages to the Mac. We've talked about it. You guys have heard me bitch about mine on the regular. But the advantage of it is that at Apple headquarters, the guys who designed the hardware are right down the hall from the guys who designed the Mac OS. So they work closely with each other. They have total access to each other. They achieve a level of performance out of certain things and certain hardware that Microsoft and Dell, for example, can't. Microsoft and Dell work very well together, I think. Windows 10 runs great on Dell's. Dell's a decent computer to run it on. They work great together, but they don't work as well together as Apple does with itself. And now Apple has removed pretty much any external entity. They're making their own processors. They're designing their own processor. And they're putting stuff in it that's purely for their design. So what does this mean? This means that they can get weird. And this is how they're getting weird. This is a normal, like conventional Mac motherboard. You see there's a CPU. The memory is over here. The I/O chip is over here. The Apple T2. This is like a TPM chip, like a security encryption chip. And the Thunderbolt controller, like all these chips are separate, right? Well, with this new chip, it's based on their mobile design, but the chip contains everything. It has the GPU inside it. It has all the memory in it, and both the processor and the GPU share it. And that sounds terrible because it normally is on a computer. And it's, again, ARM architecture. But if you look at what's in here, you have the CPU, GPU, RAM, something called a neural engine, which I don't quite understand yet, and a cache. And they all share this same RAM, but they're so physically close to each other. They are smushed together. And so, what does this mean? Well, so far, Apple has only released a couple computers that use their new chip. They're still on Intel's for their others, but we expect they're moving to it. And it's a $900, like $899 Mac laptop. It is like, hang on, let's just look at it. Let's just look at it. What do you say? It's right over here. Here's the new guy. $899 for education, which is you guys. So this thing is their cheapest MacBook. It's a very cheap computer. And let's see how that goofy, or rather, where's the Mac Pro? This one. How much is this guy? $1199. So let's talk about this one. Let's be fair. $1,200. So this $1,200 MacBook, the entire laptop's $1,200. Here is how it performs on Cinebench. We're going to get into performance testing in a second. This basically runs the computer through a test. It's like a series of sprints and heavy lifting to see how powerful it is, and then it assigns a number based on the performance. And here we see many chips that we all know very well. The Intel Core i7. You see an i9 is right here. There's Ryzen's. These are all pretty strong type processors. And here is the Mac Air, and here is the MacBook Pro. So this is what we would put in a really big build. Like this is what you'd put in a $2,000 gaming PC, and it's scoring a 1,500. And here is this $900 Mac and this $1,200 Mac scoring similarly. That's really weird. It's got the whole industry flipping out about it. Oh, and the other thing is that new Air doesn't have fan. So it's probably less powerful, barely, than the Pro because it doesn't have a fan, so its top speed is limited. Like its performance is limited by how much heat it can dissipate. So that's the difference. I'm going to include this video. You guys might want to check it out, but it goes into great detail on what they've done and kind of what they're up to. Okay? Let's see. We don't actually. No, we don't want to play it right now. I'm going to go on to the next slide. So that's what Apple's up to. Okay. Put it. Boop. There it goes. So performance testing. How did they get that Cinebench score to test those new machines? Well, Cinebench tests with video rendering. It's all business. It's not about video games or anything like that. It basically takes a chunk of video, like say this scene from Ford and Ferrari, and turns it from its unedited form into a form that could be uploaded to YouTube, printed on a DVD, whatever. That's called rendering, and it takes a powerful workstation type computer to do it. So Cinebench sort of fakes that. It just renders some garbage footage and judges how long it takes the computer to do it. And then you can compare that number as you run the exact same test on other computers. Geekbench, similar thing. This is your homework for the week, is to Geekbench your computer. We'll get to that in a second. 3D Mark actually tests 3D performance. That is applicable to video games, AutoCAD, things like that. And then Rob likes something called Performance Test, which you can just Google, Performance Test Computer Test. And it's most of these have a free version and a paid version. This is how you get Geekbench. Go to geekbench.com/download. Download for Windows or Mac or whatever your operating system. You don't have to do the phone version. It costs $1. I don't want you guys to spend money. So the Windows version is free for a trial. When it starts up and asks about tryout mode, you click later, leave me alone. And then you just run CPU benchmark. Takes a couple minutes. When it's done, screenshot that and email it to me. That is your homework. Okay? And here's a bunch of computers of mine that I tested. This is a gaming PC that I built. It's okay. It's getting kind of old. I built it 4 or 5 years ago, but it's a Ryzen 5 and it's not bad. This is a workstation I built at work for a video editor, in fact. It's a little bit nicer. It's a Ryzen 7, and you see the difference. It outperforms the 5. This is a really old Dell I had laying around that I got Windows 10 on. All these except the Mac are Windows 10. And so you can see this is a Dell. This is like the first i7 they ever made. It's 7 or 8 years old, maybe a little more. But it still hangs in there, kind of. It's still useful. This is a brand new Dell. Like these are even newer than the ones that we have in our classroom. This is a brand new guy. i7 8700, and you see it outperforms my older generation Ryzen's. Although it underperforms in multi-core. Interesting. It's probably because these Ryzen's have like 6 and 8 cores respectively, and this might be a quad. Now the Alienware laptop, some of you guys see me bopping around with it. It is for our VR setup, and it has apparently a big old 8759H in it, and look at that. It outperforms all of these, including the Ryzen 7. It almost catches the desktop. See this? This is an $1,800 laptop compared to a $800 desktop, and they're very similar. Okay, and then my MacBook Pro that I love/hate has an i7 in it, and you see it scores comparably. It's a little more limited. It's throttled down. It's not as powerful as the Alienware, even though they have just one generation apart on the chips. So what if we throw out these two junk computers and put in those two MacBooks, $900 and $1,200? In Geekbench, they look like this. They're practically doubling the performance of some of these. This is a huge leap forward. And right now, Intel has been kind of getting their butt kicked by AMD in the PC building wars. Most PC builders right now are recommending you build with Ryzen. But Apple's chips probably not going to be available to anybody but Apple's. And Apple still has shown no sign of making a decent gaming computer. They'll crank out with this super duper processor, but it doesn't have a good graphics card. So we don't know what its game performance is yet. These things are just hitting the shelves. And like I said, the only machines they're putting it in are very low end machines. But this is a low end machine in a crowd of medium to high end processors, and it's way ahead. So every so often the industry does this. Somebody pulls a little bit ahead. For the longest time, it was Intel, and AMD looks like they're about to do it right now with the graphics card. NVIDIA came out with the 3070 before they were ready to because they were worried about AMD coming out with their new card, which seems to be better. And then Apple does this. So it's just total chaos, cats and dogs living together, mass hysteria in the processing world right now. So send me the Geekbench of your computer. And let's compare it to these. We'll compare it to the venerable old Dell that I got running here. We'll compare it to these new crazy things Apple's doing. But right now, if you're Intel or AMD, what you're worried about is that they can scale this. You're worried that this is the low-end M1, and they have a high-end M1 that really makes you look bad. So we'll see about that. And then tomorrow at 5 p.m., we're going to do some certification practice. Wednesday at 5 p.m., we're going to do some certification practice. And next week's the final. You guys are almost free. You've almost made it. Really proud of all of you. You've done great despite COVID, limited access to the lab, all kinds of chaos in your lives. A bunch of you had to be quarantined several times. You guys have been incredibly stoic throughout all of this. There's been no complaints, no flip outs. Everyone was just civil and professional, and you got pretty good grades overall, honestly. So thank you. You're a good bunch of students. You're definitely well above average from what I have seen. So I know you're going to do well. Okay. Bye.